All right. For those that are looking for seats, there's plenty of seats up front, always. For those that trickle in late, if you missed the seats that you had. Thanks for having me back. I was here last year to kick this off. How many folks were here with me last year? It's pretty good. And a lot of new folks. So, I think this will be a good grounding for everything that you're going to hear and see today. For those that have hopefully had some great talks this morning already about the status of the programs, and you'll hear from various customers and partners, other developers in the room on how they're utilizing these different tools to optimize their software to really take advantage of all that the hardware has to offer. You're going to see a big shift at Intel if you haven't seen in the market already with some of our disclosures that Raja Kaduri has done, who now runs our overall software programs, to really make sure that we're best bringing forth the tools that help to unleash all the performance that is inside the hardware. And I like to quote Raja often. He has a little saying, no transistor left behind. So, we need everyone in this room to do the software innovation to really unlock the performance. And I'll show you just a few examples today of what that's about. Of course, this event isn't all about the keynotes or the talks from the customers. It's also, there's some great demos. I really encourage you all to go out and meet with both the Intel folks as well as we've got some partners who have demos that they've put together and are sharing how they're utilizing these tools today, and the networking that you have and how you can help each other after this event. So please take full use of the time that you have here and enjoy all that there is available. So new technology, it does take a long time to cross that chasm. If you think of Jeffrey Moore, he kind of coined this model that there's always these innovators and then the early adopters, but to really bring technology to the mass market, you have to cross that chasm. Intel has been innovating for many, many years in the storage media space, in the industry standard space, trying to really bring forth and break through the bottlenecks that we see in the overall storage platform. We can do that innovation, but the hardware is only going to achieve so much without all of the investment that the folks in this room make to help unlock that performance and to really innovate on top of the hardware innovations that we have. Our examples that we have in this space would include that Optane storage, the Optane SSDs that we have, our brand new Optane data center persistent memory modules, but of course the industry standards, and I'll talk to you a little bit about our EDSFF form factor in the SSD space that we just launched recently. So really, it takes the whole industry to help us cross that chasm and take advantage of the innovations that all the hardware folks are hard at work on. Looking at that adoption, I was really excited to see that the team pulled together not just the SPDK organization and the tools and the experts there. We, of course, talked a little bit about PMDK last year and how we've put that out in the industry several years ago to prepare for the Optane data center persistent memory that we've launched. But you've also now seen that we're going to be including the vTune analyzer and amplifier here to help you really understand the workload analysis that's on the platform. So that as a developer, you know where to spend your very precious time focusing on breaking through the bottlenecks. And you can get the best ROI for your hard-earned time. So you'll see that throughout today, we're going to be covering all of those. After I leave the stage, Ken's going to join to talk a little bit about the PMDK, and then Shri a little bit more detail on the vTune amplifier. These are the tools that are going to help you to unleash the innovation that is inside these technology products. And you can think about the software applications that have been developed over decades to take advantage of the existing technology. When you get something as innovative as the incredibly low latency of an Optane SSD or this Optane data center persistent memory. It's fundamentally breaking the structure of what has previously existed. Rather than continuing to rewrite that code for every technology change that comes forth, we're really investing in ensuring that we're making it easy for you to write once and to get the performance out of the innovation that happens on the hardware underneath. So that's why, really utilizing all of these tools is going to deliver the best ROI for you as a developer to get the most out of that, because I think we all know in this room technology is not going to stop changing. That's a constant. So here we are. A few weeks ago, we had a pretty major launch for Intel. It was our first data-centric launch. And when we think of data-centric, we really look at everything from the multi-cloud, so whether it's a public cloud, a private cloud, or even to the edge. And we're seeing a tremendous amount of growth at the edge. And all of the products that we launched span what we call our move, store, and process strategy to really deliver products that will address the needs from the edge to the data center and back as the workloads and the needs change over time, right? With autonomous driving, we're gonna need a lot of performance at the edge, but we need to check back in the cloud and make sure that everything's been updated. So you'll see this whole suite of processors, it builds out. So there's a lot that we launched here a few weeks ago. I'll just touch on it briefly. The first was in that process area. So we really want to make sure that we're delivering products that process the data everywhere and all data. And so what you see we announced here were 3 different families. One was our 2nd generation Xeon Scalable product. And the middle is the product, the Xeon D1600. And that's really targeted at edge use cases with lower power. And then for flexible acceleration, we announced something that I'll look forward to bringing forth to future summits as we get closer, is our new Agilex family. And what that is going to bring forth is a new cache coherency for the FPGA with the memory, both on the cache and the CPU, as well as the system memory for that CPU and the Optane data center persistent memory. So a whole lot of new use cases will be opened up with that cache coherency. In the move space, we announced new products called the Intel Ethernet 800 series adapter, and that delivers Ethernet speeds up to 100 gigabit and delivers the new features RDMA and Rocky V2 iWarp. So we've got a lot of new hardware products. There's of course new storage products, including the Optane data center persistent memory, and 2 new products that I'll speak to on the next slide in the storage solutions. Another focus area for Intel is ensuring that the products that we deliver, that security, I think we all lived 2018 together. I know for me it started probably around Christmas of 17 with Spectre and Meltdown and preparing for those announcements that were about to come, and there were a lot of other heightened security news throughout the year. So cybersecurity is a #1 pain point for CIOs around the globe. It's something that everybody is thinking about. Sorry, I'll click through. And so another thing that we launched at our data-centric launch on April 2nd were some new security libraries that include ways to monitor side channel attacks. Intel threat detection technology is embedded in this security library, and it basically is using machine learning to understand what predictable behavior on your system is. And it will basically learn over time when there's anomalous system behavior. Of course, we're always building in accelerators for encryption algorithms into the product families as well. And the last piece, why we're here today, is how do you help enable these products to be deployed? That's a lot of products, right? It's a very broad portfolio. But we know that it's this Intel software and the investments we make, or in the solution stacks. We put something together called Select Solutions that basically we work with ISV partners to put a reference architecture together that meets a certain benchmark standard. And that's very easy then for an enterprise IT to deploy. It saves them time to money, they don't have to do as much testing and validation, and it's a known good solution. So we're really continuing to invest. We already do a lot today in the software that brings all of this together and unleashes the full value. So to talk a little bit more about those storage products that we announced, you've probably seen this slide. Previously, I think we covered it for certain last year. The storage space, as I mentioned, is this area that Intel's been innovating for over a decade, building that new storage media that goes inside the Intel Optane SSDs as well as in the DIMMs. Up until now, you were reliant on that fast, expensive DRAM, and it had very limited capacity to achieve all of the needs. And so, when you're bottlenecked on the capacity, you're now dependent on the latency of moving that data to the SSDs. So Intel really innovated here to put forth that new Optane data center persistent memory. We'll look on the next slide at what some of those latencies look like, just to really bring it home for you, what that advantage is. And this is really an affordable, large capacity memory module. And so, wherever somebody is looking to deliver greater memory, if memory is your bottleneck, this is a great option. It has two modes. One is memory mode, where it can just plug in and software work isn't required. And then the PMDK will help you take advantage of that persistence in its app direct mode that it has. We launched additionally 2 SSD products. The first one was a dual port Optane SSD. And that, of course, delivers the highest availability, having the independent storage controllers, as I'm sure many in this room are familiar with. So we're excited to see those products will be deployed for highest availability, 24/7, 5, 6 nines of 30 seconds of downtime a year. It's pretty incredible. The last piece is that what we call the ruler form factor, that EDSFF. And it's basically about a foot long. And this is one of those industry standard innovations that Intel took on. If you think about a server platform, why, now that we have this new flash media, are we beholden to the form factor of spinning media from so many years ago, whether it was 3.5 or 2.5 inch form factors? So what this new product family does is it really enables, it breaks through and takes advantage of all the capabilities of the flash technology, and you can now put up to a petabyte of storage into a single one-use server because you're breaking through and enabling greater density because of what the technology enables. And now that we have a new industry standard form factor, everybody can now build their products in order to meet this need. We see this built with QLC media as a warm storage replacement. So it's cost effective, it's very dense. You can bring a lot of media, or excuse me, a lot of data into that warm storage tier. So a lot of innovation, new products announced just 2 weeks ago. But why are we innovating on this? It's really about the fundamental challenges that were present in the former technologies. And you can look at the left side of the graph, the 75 microseconds of latency. Also, could be translated as 75,000 nanoseconds for an SSD. When you move to the Optane media, it's incredibly faster at 10 microseconds or 10,000 nanoseconds. Now, bringing that storage media onto the memory bus breaks through and opens up even more innovation. I don't know if anybody can see the little blue line on the far right. I think it's pretty hard to see, so let me blow it up for you. The 100 nanoseconds, it's nearly zero compared to the storage architecture that you were writing your code for up until now, right? I mean, up until these new medias were available, the software was trying to compensate for the latency present in the hardware. Now that you have this available to you, just imagine what's possible. We'll see use cases. I'm not sure what all Ken's going to be sharing, but technology like this has provided breakthroughs. We did a lot of, shared a lot of examples at our launch around SAP HANA and restart times going from hours to minutes. You know, the data's persistent as well. So really unleashing a completely new level of hardware capability. But unless everyone in this room, you know, puts their effort to take advantage of this, it won't be fully realized. The performance advantage, the ability to bring all of that data closer to the CPU, it won't be fully realized unless we take advantage of the software work that all of you in this room do today. So it's kind of a yin and a yang. We need the hardware innovation, we need the software innovation. We know on the hardware side, there's continuing innovation as the Ethernet speeds are increasing to remove that bottleneck of moving the data. Now we've got the persistent memory. You know, Intel is just one of the persistent memory vendors coming out. SmartNICs are now changing the way the data is moving inside the infrastructure. So all of this hardware innovation means that we really need to be spending an equal amount of time on that software innovation. So you'll hear today about all these various tools that we're putting together to at least take advantage of our products, and often they scale beyond to many others. What's happened in the last year since I talked to you? This is just a few examples of performance improvements over the last year. So in SPDK, we're now seeing up to 5x improvements on the FIO benchmark using NVMEs. It's incredible. Our OpenCAS framework, which we'll talk a little bit about, is also seeing a 5x improvement on that Ceph workload using the Optane as a cache. And PMDK, again, that's our memory development kit. Cassandra seeing an 8x performance improvement in both reads and writes. And when Shri will talk a little bit about this vTune amplifier, over 2x improvement for Netflix. That doesn't sound like as big of a number as the ones on the left, but when you think about Netflix moving 30% of the internet traffic every night, that's a big, big number. Has a big impact when it's a 2x improvement on their throughput. SPDK. So probably you know what SPDK is. It's why you're here. We offer services like the logical block volumes, showing an SSD as 20 different SSDs. We have our the key value store with RocksDB that we've put together. We support multiple protocols with the iSCSI and the NVMe over Fabric, targets, and initiators. It supports VirtIO. We offer drivers for the NVMe SSDs, for the persistent memory that's being delivered, and of course, virtualization with the SPDK vhost. And that enables near bare metal performance with all the functionality of virtualization. So a lot of capabilities in this toolkit that we're offering. And really, if you look out here, I saw some of the demos, and even from our partners, are taking advantage of that hardware innovation with SPDK. So I think you're going to hear later today from Mellanox around their SmartNIC innovation. I can't remember the name of the partner out here. They have the open channel SSDs in their demo, just right outside the front door here. So we're continuing to see a lot of momentum here, really taking advantage and evolving, which is what we're hoping to see from this community. So thank you for all your investments and continuing to move this project forward. I was going to take a minute to look at one example of a very large customer using SPDK. I don't know if anybody in the room's heard of Alibaba's Singles Day. It is November 11th or 11/11, and they move $31 billion of revenue in a single day, over $5 billion in an hour. By comparison, the US Black Friday through Cyber Monday is only $18 billion. And that's over 4 days. So a tremendous amount of volume and transactions, and what they were able to do was to deliver using SPDK and the Optane SSDs, a 4x improvement in their infrastructure. You can see in the IOPS an improvement in the latency. And this was a pilot project that they had started just over a year ago, but they put it into full deployment this year. So really a tremendous capability for them. I have a lot to cover and time's going, so I'm gonna move forth. They utilize SPDK in other places as well, right? Ali's public cloud, and they have high performance VM solutions. They use SPDK as well to improve the performance for that family of products that they have as well. A big announcement that we have, I think you'll be hearing a little bit more if you haven't already, is our Intel CAS, or Cache Acceleration Software, is now open. We've moved that engine, the Intel CAS caching engine, into open source. It's available on GitHub today. We talked about that performance improvement number. We're doing this because we believe that we're going to see more innovation if we can put this into open source and allow everyone here to contribute and innovate on top of this platform. We think this is going to really help unleash the benefits that you saw on that prior slide with the very low latency of the Optane SSD. So we want to make sure everybody has access to innovate on top of that, and so that's why we're moving OpenCAS framework out there. There's the URL for GitHub. To enable it to be useful from day one, we're putting the SPDK adapter out there, as well as the QEMU and Linux OS adapters, and these are basically the tools that enable it to work in these different environments. We hope that the community will add more over time, and we look forward to that innovation. There's going to be some hands-on labs later today and tomorrow, so I'd encourage you to meet with the team and learn all about the OCF, or OpenCAS framework, and see what you can, how you can support that new project. PMDK, you'll hear more from Ken about. Similar to the other pieces we've talked about, PMDK is going to help you deliver your software faster time to market. We started it many years ago supporting NVDIMMs, and of course it supports the Intel Optane data center persistent memory today. So it's vendor neutral. It allows you to write your software, and it will best take advantage of whatever hardware is underneath it. So I think this is a very powerful tool that will allow your applications to get the most out of those extremely low latencies that we had seen in that prior foil. This is that Cassandra example where they essentially took out their caching algorithm that was caching to DRAM, and they replaced it with a storage engine that now allows them to store terabytes of data in memory. And when you're using something like the Optane data center persistent memory, they also is always available. So should there be a server outage or a power outage, that data is still available and ready to be used, and will enable, whether it's a cloud service provider, to bring that service up more quickly, and the restart times are significantly faster. Sheree will come up after Ken to talk a little bit about the vTune amplifier. You've got all this technology now, you've got your application, and how do you know where the bottleneck is? What the vTune amplifier does is it helps you to analyze the memory and storage within the system to help point you to where that bottleneck is. So this is a really powerful tool that's going to let you, best manage the configurations for your clients, for your customers, in your own infrastructure that you're deploying. And if you haven't used it today, I really encourage you to go look at it. We'll just look at one example from a customer. HPE was trying to grow their data set and for their big data workloads. After they reached a certain data set size, the application kept crashing. When they ran the vTune amplifier, they were able to understand that the memory utilization was reaching 100%, and their disk I/O and the page faults were spiking. By adding more memory, in this case they added the Optane data center persistent memory in memory mode, they were able to grow the total footprint, remove that memory bottleneck, and allow the larger data sets to continue to be processed. So that's just a simple example of the vTune amplifier in use. ISA-L, our intelligent storage acceleration library, provides those foundational algorithms for storage. And this could include erasure coding, dedupe, snapshots. The goal here is to help ensure that you have performance tuning from day one as you're writing your application when you utilize these libraries. You don't have to wait till the end of your cycle to then go do the performance tuning. We have licensed this with very permissive BSD terms, and what that means is that you can utilize it either in commercial or open source software, and you can even find it in use today in the Ceph and Swift examples. So because it's software acceleration, this means that you can deploy it on an existing fleet as well as the new hardware. So really, you can get the performance advantage utilizing the ISA-L for current and future platforms. Another example from Netflix, they use ISA-L for encryption, and they're encrypting tens of terabytes of video traffic every second, every day. So really, you can see these tools get used at scale. This is an example of some of the progress that we've seen in ISA-L just over the last year. So on the left, you can see that there's been improvements and contributions that enable small block compression to increase by up to 3x. We're now seeing compression at 6x versus zlib. And again, gen over gen, tremendous improvements in hashing as well as erasure coding, the 3x and the 2x you see there. So that's all the work that we're putting forth to make sure we're unlocking the value of the latest hardware that we have. So in summary, I just wanted to take a look at how has the community grown over the last year. We looked at some stats last year. We had 2 different summits, one in the US and one in China last year. We are continuing to see growth in the number of attendees and the engagement in the community. We had developer labs. We had one of the community members, NetApp, host a meetup. We'd love to see more of that. Many companies engaged, and you can see over 1,000 followers on GitHub. But on this slide, I think the most impressive statistic that you see is the increase in the committers and the amount of external patches delivered. Because these projects get better when everyone is engaged and when it's being used in a real world workload like you see in your labs and in your daily lives. That's where we can really see the improvements. So did anybody in this room submit some of the 250% improvement in the external patches? Raise your hand. It wasn't me, I'm just raising my hand. Nobody? Wow. They must think they know everything about this already, Sri, sorry. We'll have to invite them back. That's a tremendous amount of investment in the community. So we look forward to seeing more from those of you in the audience. To me, that's what this is about, which is why we're considering moving the SPDK project into open governance, similar to what we've previously done with the DPDK project in the past. It just opens up board participation for community members and provides other support for trademark and legal. If this sounds interesting to you, you can talk to any of the Intel folks here about what you think of moving this into open governance. If we do this, there are things that don't change, right? Everybody continues to contribute, everybody can continue to utilize the content, there's no fees, everything else remains the same. It just gives the project to the community. So please find an Intel person and share your thoughts on this. We'd appreciate it. And in summary, please engage, right? I mean, one step is coming to the summits like these, learning about what's new, learning from your peers, how they're utilizing these tools, how they're unlocking performance, seeing the demos, talking to the experts about how they're unleashing the performance, interact with the community that you have here, and to contribute. So that's all I had for today. I thank you for your time, and I'm going to invite Ken to the stage to talk a little bit about PMDK. Thank you.